Hello, hi everyone. Welcome to the Student Brand. This is your Siva sir. Today topic is electric current. CBSE Grade 10 Physics. The electric current. In the electric current, so we'll discuss about current definition, electrical appliances, and Ohm's law. After that, resistance and resistivity. After that, resistors are connected in series combination. After that, resistors are connected in parallel combination, and the heating effect of electric current. So until that one we will discuss now. So you can observe here electric current. Electric current is nothing but rate of flow of charge. Electric current I equal to Q by T. I equal to Q by T. The flow of charge through unit cross section area per second. The flow of charge through unit cross section area per second is called electric current. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. So the flow of charge through unit cross section area, the flow of charge through unit cross section area is called electric current. So now you can observe here. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb, and SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. I equal to Q by T. So here, right now, so we'll discuss about electric current is completed. Now charges are moving in the conductor. Charges are moving in the conductor. So here only one electron if it is flows, can we say current is flowing? Only two electrons if it is flows, can we say current is flowing? Only three electrons if it is flows, we can say current is flowing. So we can't say like that. So number of charges are moving in the conductor. Number of charges are moving in the conductor. Then only we can able to say current is flowing, right? Here, so we can take I equal to Q by T. Q is nothing but quantization of charge. Q is nothing but quantization of charge. Q equal to Ne. So N is number of electrons are flowing in the conductor. So N is, if you are taking here, so here you can observe Q equal to Ne. Q equal to Ne I am taking. So N is nothing but number of electrons are moving in the conductor, right? Yes. So here I equal to Q by T, Q equal to Ne. So SI unit of charge is coulomb, and here on one electron 1.6 into 10 power minus 19 coulomb. So on one electron how much charge is present? On one electron how much charge is present? 1.6 into 10 power minus 19 coulomb. In 1 coulomb how many electrons are present? In 1 coulomb how many electrons are present? We'll discuss now. So on one electron 1.6 into 10 power minus 19. So in 1 by 1.6 into 10 power minus 19. So if you are taking 1 by 1.6 into 10 power 19. So if you do this, so you'll get it. If you do this, you will get that is 0.625 into 10 power 19. If you do this, 6.25 into 10 power 18 electrons are present. So in 1 coulomb, so 6.25 into 10 power 18 electrons are present. So this is very, very important. Very, very important. So 6.25 into 10 power 18 electrons present. So just check once. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. 1 ampere equal to 1 coulomb per 1 second. Q equal to Ne. On 1 electron 1.6 into 10 power minus 19. In 1 coulomb, so 6.25 into 10 power 18 electrons are present. So this is about electric current. So and define. So they will ask about define SI unit of electric current. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So that is called electric current. Electric current. I hope it is very clear, right? Yes. Now We will discuss electrical appliances. Electrical appliances. So are you ready? Yes. Let's start. Electrical appliances. What are those electrical appliances? Electrical appliances are nothing but cell, battery, open switch, closed switch, ammeter, voltmeter, and so we can take wire joining, wire crossing, and bulb. Wire joining, wire crossing, and bulb. So these are the electrical appliances. Now we'll see. So cell. So first one is cell. Positive terminal, negative terminal. Coming to the next one, battery. Battery. So coming to the switch, open switch and close switch. Open switch. Open switch. And fourth one is closed switch. Closed switch. This is the closed switch. And fifth one. And next one we can take resistor. This resistor and rheostat. So either like this we can take, or we can take like this also. Like this also. And coming to the seventh one. So here a bulb symbol I am drawing like this. Bulb. And eighth one. Meter. Positive terminal, negative terminal. Ninth meter. And the next one, 10th one. So wire joining. 11th one, wire crossing. And 12th one is, any other point is left? Wire joining, wire crossing. That's enough. So open switch, close switch, cell, battery, ammeter, voltmeter. Yes. Any other thing? Just let me know. Okay. So here you can see cell, battery, open switch, close switch, resistor. Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. Resistance is the phenomenon of opposing electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. Resistance is the phenomenon of opposing the electric current in the circuit. Okay, and SI unit of resistance is ohm. SI unit of resistance is ohm. Now you can see here rheostat. Rheostat is a device which is used to regulate the current. Rheostat is a device which is used to regulate the current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. So that is about rheostat. And coming to ammeter. Ammeter is a device which is used to measure the current. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. So ammeter is connected in series combination in the circuit. Ammeter is a device which is used to measure the electric current in the circuit. So it will be connected in series combination. Coming to the voltmeter. Voltmeter is a device. Voltmeter is a device which is used to measure the potential difference. So voltmeter will be connected in parallel combination. Voltmeter is connected in parallel combination. Once again, ammeter is a device which is used to measure the electric current, that is connected in series combination. Coming to the voltmeter, voltmeter is connected in parallel combination. Voltmeter is used to measure the potential difference. Okay, so next one. That's enough. So this is about electrical appliances. We'll discuss about electrical circuit. Electrical circuit. So electrical circuit we'll discuss. So what is electric circuit? A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. Okay. So here we can see. Cell, I'm taking the battery here, and submeter and bulb, switch. So current is flowing like this. So bulb. So positive terminal, negative terminal, current is flowing I, and here also I. So here you can observe current is flowing. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So here you can see, and here, so 2 points we need to discuss. So 2 points we have to discuss. Those are conventional current and electric current. Conventional current, so conventional current is nothing but flow of positive charges. Flow of positive charges is known as conventional current. Flow of electrons is known as electric current. So positive charges will move from positive terminal to negative terminal. Okay, so positive charges will move from positive terminal to negative terminal, whereas electrons will move from negative terminal to positive terminal. So positive charges will move from positive terminal to negative terminal. Electrons will move from negative terminal to positive terminal. Negative terminal to positive terminal. Okay. So here you can observe. So flow of positive charges direction is taken as conventional current direction. So flow of electrons direction is taken as electric current direction. Okay. So here positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Very, very important. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Very, very important. So based on this one question will come, either 1 mark question or 2 mark question. Surely they will ask in exam. So be careful, listen careful, and learn carefully. So here flow of positive charges. Positive charges direction is considered as the electric current, a conventional current. So conventional current. So flow of electrons is known as electric current. So here positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential. Here you can see. So positive charges is high potential, whereas negative terminal is at low potential. So here positive terminal is at high potential, negative terminal is at low potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. So electric circuit is nothing but the flow of a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as electric circuit. A continuous and closed path of an electric current is known as electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay, so electric current already we know. So electric current. So the flow of positive charges is known as electric current. I equal to Q by T. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere equal to 1 coulomb per 1 second. So that is electric current. And coming to the electrical appliances, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing. So all these things we discussed. Now here we are discussing about electric circuit. Electric circuit is nothing but the flow of positive charges. a continuous and closed path of an electric current. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. So conventional current is nothing but flow of positive charges. Positive charges will move from high potential to low potential. So electric current. So electrons will move from low potential to high potential. So this is about conventional current and electric current. So I hope it is very clear. Next one. So we'll discuss about one more. Now, so we are discussing about one more. Potential difference and electrical potential. Potential difference. Potential difference. Potential difference. Potential difference is nothing but, so work done to move unit positive charge. We are doing some work to bring unit positive charge from one point to another point within the conductor or within the field. Okay, so within the conductor or within the field is known as potential difference. So here you can observe, I am taking this is one point. So this is point A I am taking, this B. So positive charge is there. We are doing some work. Okay, to bring unit positive charge from point A to point B. We are doing some work to bring unit positive charge from one point to another point. So that is nothing but V equal to W by Q. V equal to W by Q. So V equal to W by Q. So work done to bring unit positive charge from one point to another point within the conductor, within the field is known as potential difference. V equal to W by Q. V equal to W by Q. I hope it is very clear, right? Next one. So SI unit of potential difference is volt and SI unit of work is joule. SI unit of charge is coulomb. So 1 volt is equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point. One point to another point. I hope it is very clear. Next one. Electrical potential. Electrical potential. Electrical potential. So electrical potential is nothing but electrical potential. So we are doing some work to bring unit positive charge. So if you are taking this the field, so this the infinity positive charge is there, is at infinity. We are doing some work to bring unit positive charge from infinity to the required field. So we are doing some work to bring unit positive charge from infinity to the required field is called yes, correct on. Work done to bring unit positive charge from infinity to the required field. Okay, it's called electrical potential. Coming to the potential difference is nothing but work done to bring unit positive charge from one point to another point. Okay, so here is the difference, small difference. So both the definite, almost formula is same. Formula V equal to W by Q only, but in definition it will be different. Okay, work done to bring unit positive charge from one point to another point within the conductor or within the field. So from one point to another point within the field is called potential difference. And so here work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Electrical potential. I hope it is very clear. So this is about potential difference and electrical potential. Potential difference and electrical potential. Coming to the Ohm's law. So now we will discuss about Ohm's law. Ohm's law is nothing but so the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay, so once again listen carefully. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay, so V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. So the potential difference across the ends of the given metallic conductor. So I am taking here, so Ohm's law we are discussing now. Ohm's law. Ohm's law. Okay. So now you can observe here cells. So we have to take 4 cells. 4 cells we have to take ammeter. So this is the ammeter. And here I am taking the resistor and potential difference across it. We are connecting voltmeter to measure the potential difference. Okay, so now you can observe your cell and switch or switch. I connected here switch. This is the switch. Okay, I'm connecting the switch. Now here so current is start flowing. First one you can observe here. This is the metallic conductor. So the potential difference across. So here you can observe. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So that is the Ohm's law. Here, what are the required materials? So what are the materials we require to do this activity? Here now you can observe point number one. Point number one. So V is directly proportional to I. Materials required, this is a statement. And V equal to IR. V equal to IR. Materials required. Materials required. Required materials. Materials. Material required. So point number one, 4 cells. So we need 4 cells of 0.5 volts each. 4 cells of 1.5 volts each. And the second thing is we need nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So nichrome wire is an alloy of nickel, chromium, manganese and iron metal. Okay, and coming to the next one, voltmeter, ammeter, and fourth one is ammeter, voltmeter, and fifth one is so switch, we need switch, and the next one is sixth one is we need connecting wires. So next one connecting wires. So once again you can observe here what are the materials required. 4 cells of 1.5 volts each. 4 cells of 1.5 volts each. So here 1.5, 1.5, 1.5, 1.5. So 4 cells we need. And next one, nichrome wire is an alloy of nickel, chromium, manganese and iron metal. And voltmeter, ammeter, switch and connecting wires. So these are the materials required. These are the materials required. Okay, so thank you so much for subscribing. So next one you can observe these are materials required. Next one, procedure. What is the procedure to do the activity? So first you have to take one cell. First you have to take one cell and connect one cell and note down the reading of ammeter and voltmeter. Okay, so first connect one cell and note down the reading of ammeter and voltmeter. Next one, connect two cells. Connect two cells and note down the reading of ammeter and voltmeter. So first you have to connect one cell and note down the reading of ammeter and voltmeter. Next, connect two cells and note the reading of ammeter and voltmeter and repeat the process. Okay, so you have to repeat the process for 3 and 4. Okay, so repeat the process for 3 and 4, 3 and 4, 3 and 4. Okay, then mention the values in the tabular form given below. So you have to mention all those values, whatever you observe and measure. So all the values. So here you have to mention in the tabular form. So you can see here serial number, number of cells, and ammeter reading, voltmeter reading, V by I equal to R. V by I equal to R. So 1, 2, 3, 4. 1, 2, 3, 4. Here you can observe. Okay, ammeter reading. Current is nothing but ammeter reading. Voltmeter is nothing but potential difference. So that is nothing but voltmeter reading. So you have to draw the graph. See here you can observe V equal to IR from Ohm's law. V equal to IR from Ohm's law. V equal to IR. I equal to V by R. I equal to V by R. Sorry, R equal to V by R. R equal to V by I. R equal to V by R, correct? R equal to V by I, yes. So here we need to find the resistance. Finally, we need to find the resistance. So find the resistance. Okay, so we need to find the resistance. If you draw the graph for VI, so the graph is like this. The graph is like this. Potential difference on y-axis, current on x-axis. If you draw the graph, okay, the graph is linear. The graph is linear. Okay, if you draw the graph for VI, the graph is linear. So starting from origin. Okay, starting from origin. So by observing the graph, we can understand. So V is directly proportional to I. V is directly proportional to I. So V is directly proportional to I, means potential difference is directly proportional to current. That's why it's starting from origin. So it is a linear. So and also this is applicable for ohmic conductors. Okay, so this is applicable for ohmic conductors. Ohmic conductors is nothing but the conductors which obey Ohm's law, the circuits which obey Ohm's law. We can take the resistors which obey Ohm's law. So all these things. So the conductors which obey Ohm's law, those are called ohmic conductors. So non-ohmic conductors. For non-ohmic conductors, the graph is like this. So it is not straight line passing from origin. So it will be curve. You can observe like this. So like this. Okay. So this is for ohmic conductors and this is for non-ohmic conductors. So this is for ohmic conductors and this is for non-ohmic conductors. Non-ohmic conductors. I hope it is very clear. So Ohm's law, once again, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. Materials required 4 cells. So 4 cells of 1.4 volts each. Nickel wire is an alloy of nickel, chromium, manganese and iron metals. Okay, ammeter, voltmeter, switch, connecting wires, And procedure, first you have to connect one cell and note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. Okay, so you can see by measuring ammeter reading and voltmeter reading, so mention in the tabular form given below. So you have to mention all those values in the tabular form. If you draw the graph for VI, the VI graph is straight line or linear passing from origin. So V is directly proportional to I. So this is applicable. So the graph is for ohmic conductor, the conductors which obey Ohm's law. Here the conductor which does not obey Ohm's law, those are called non-ohmic conductor. The conductor which obey Ohm's law, those are called ohmic conductors, or resistors, circuits, anything we can say, that is for ohmic conductors. So I hope it is very clear. Next one, we are going to the one more, resistance. So just now we discussed about resistance, right? So proportionality constant. And also Ohm's law gives the definition of resistance. Ohm's law gives, because from Ohm's law V is directly proportional, V equal to IR. From that formula only we got resistance, right? That is the reason. So Ohm's law gives the definition of resistance. And now, so we can say like that, resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm, and a resistor is a device which is used to oppose the electric current. Resistor is the device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Okay, so I hope it is very clear. So that is about resistance and resistor. And next one, resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So R is directly proportional to L. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So rho is nothing but resistivity. R is nothing but resistance. So resistance and resistivity. This is resistance, and rho is a resistivity. Okay, resistivity. Now rho equal to RA by L. Rho equal to RA by L. SI unit of resistance is ohm, and SI unit of SI unit of area is ohm. SI unit of area is meter square, and SI unit of length is meter. Meter get cancelled. So SI unit of resistivity. Resistivity is very important. They will ask for 2 marks. Okay, this derivation they will ask for 2 marks. Even 1 mark also we can expect from here. So SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Okay, I hope it is very clear. Resistance and resistivity. And next one, differences are very important. Resistance depends on length of the conductor and area of the cross section, but resistivity does not depend on length and area. So it is a property of the material. And also resistance and resistivity both will depends on temperature and material of the conductor. So resistance, resistivity both will depends on temperature and the conductor. So very important. So these are the points. These are the points related to resistance and resistivity. Coming to the next one, resistors are connected in series combination and resistors are connected in parallel combination. We'll discuss. Resistors are connected in series combination, and next one, resistors are connected in parallel combination. Resistor conducted in series combination. Resistor resistors are connected in series combination. We'll discuss now that point. Okay, resistors are connected in series combination and resistors are connected in parallel combination. We'll discuss after that. We'll discuss about one more, that is heating effect of electric current. Heating effect of electric current. Now you can see resistors are connected in series combination. Resistors are connected in series combination. Resistors are connected in series combination. One, two, three. So there are three resistors, ammeter, and a cell, battery, switch. R1, R2 and R3. So across R1 V1, across R2 V2, across R3 V3. So from Ohm's law, V equal to IR. So in this resistors are connected in series combination. You can observe current is same. Is equal to I1 equal to I2 equal to I3 equal to I, because current is same. Coming to the potential difference is different. Potential difference is different. That's why I'm taking Vs equal to V1 plus V2 plus V3. So now IRS equal to IR1 plus IR2 plus IR3. So here we can take I common. So I'm taking I common. So the remaining values are R1 plus R2 plus R3. So we can cancel II, then the remaining value is Rs equal to R1 plus R2 plus R3. So now we can observe here resistors are connected in series combination. Resistors are connected in series combination. Then Rs equal to R1 plus R2 plus R3. Because so current is same throughout the circuit but potential difference is different. Current is same throughout the circuit but potential difference is different. So that's why from Ohm's law, V equal to IR, Vs equal to V1 plus V2 plus V3, IRs equal to IR1 plus IR2 plus IR3. Okay, so now IRs equal to I common. I am taking R1 plus R2 plus R3. So I get cancelled. The remaining values are Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. So that is the formula. If n number of resistors are connected in series combination, Rs equal to Nr. I hope it is very clear. Next one we will discuss about resistors are connected in parallel combination. Resistors are connected in parallel combination. So are you ready for? Resistors are connected in parallel combination. Okay, so now we can observe here. So you can see resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay. So potential difference is same throughout R1, R2, R3. So through R1, I1, through R2, I2, through R3, I3. So current is same, that is dividing into three parts because I am taking three resistors. If you take a number of resistors, it depends. Okay, now you can take potential difference is same, right? Vp equal to V1 equal to V2 equal to V3 equal to V. From Ohm's law, V equal to IR, I equal to V by R. From Ohm's law, V equal to IR, I equal to V by R. So for that, we can take IP equal to IP equal to I1 plus I2 plus I3. So I am taking V by RP. V by RP equal to V by R1 plus V by R2 plus V by R3. Okay, so I am taking V common. 1 by RP equal to 1 by R1. So V I am taking here also common. 1 by R1 plus 1 by R2 plus 1 by R3. So then V will get cancelled. So the remaining value is, so 1 by Rp equal to 1 by R1 plus 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, if n number of resistors are connected in a parallel combination, if n number of resistors are connected in parallel combination, here you can see. Okay, so I'm taking here R1, R2, R3. So R1, R2, R3, three resistors are connected in parallel combination. So potential difference is same. So that's why Vp equal to V1, V2, V3 equal to V. So from Ohm's law, V equal to IR, I equal to V by R. So current is dividing I1, I2, I3. So overall current, if you want to get, you need to add all these three. IP equal to I1 plus I2 plus I3. So what is IP meaning? Current in parallel combination. Current in parallel combination. So IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. So V I am taking common, V will get cancelled. 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination, 1 by RP equal to n by R. If n number of resistors are connected in parallel combination, so R 1 by RP equal to n by R, RP equal to R by n. So I hope it is very clear to you. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. Next we are going to discuss about heating effect of electric current. Heating effect of electric current. Now, so we can take here V equal to W by Q. So W equal to V into Q. So rate of doing work is called power. So P equal to W by T. So VQ by T. We know Q by T is current. Q by T is current. So we know Q by T is current. Okay. So I am taking here. So now P equal to V into I. That is nothing but VI. Now we know. So power energy is given to the conductor, so with respect to time, so now we can take P equal to Vi into T. So whatever energy is given to the conductor, that will become in the form of heat. So we know V equal to IR. Substitute V equal to IR in this format. So IR into I into T. So H equal to I square RT. So the source of energy continuously gets dissipated. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat. So that is nothing but H equal to directly proportional to square of current. H is directly proportional to resistance. H is directly proportional to time. Okay, so this is about heat produced in the conductor. So I hope it is very clear. So V equal to W by Q. So W equal to VQ. Q by T is I. So rate of doing work is called power. P equal to W by T. So VQ by T. So Q by T is I. P equal to VI. So whatever the energy is given to the conductor, E equal to PI. So P equal to VI. So in the place of V, we can substitute V equal to IR. So whatever the energy is given to the conductor, that will become in the form of heat. H equal to IR into I into T. H equal to I square RT. This is also known as Joule's law of heating. This is also known as Joule's law of heating. Okay. So I hope it is very clear to all. So if you have any doubts, you can ask me. And the notes notes PDF I provided in the link in the description. You can check. You can check in this video. So in the description, I mentioned the Telegram link in that. So light reflection, diffraction, human in colorful world, electricity, magnetic effects of electric current. 4 chapters notes is available. You can check once. So if you like the content, if you like the explanation, if you like the channel, please do like, share, and subscribe to Student the Brand. Thank you so much for giving an opportunity to teach you and listening my class with the patience. So thank you so much. So signing off. We'll see you in the next class. Thank you.